Hello there, ROS developers, and welcome to this live class number 95, where we are going to be talking and seeing some examples on basic concepts of OpenCV for robotics. So yeah, let's go for it. Alright, so hello there everybody and welcome to this live class number 95. As I've said before, we are getting super close to the live class number 100, just 5 remaining, so we are almost there. And today we are going to be talking a little bit about OpenCV, some basic concepts of OpenCV, especially in color filtering, and maybe we can see a little bit of edge detection, we'll see, depending on the time we have. So yeah, let's go for it. First of all, let me know please in the comments, in the chat, let me know if everything is fine, image, sound, if everything is working properly, so that I can keep going without issues. So I'm going to go right now to the chat and see how it's going here. I can see there. Oh, good night. Hello everyone. Hello from Gloria de Felix in California. It is starting. Yes, it is starting. All good. Does anyone know how to use deep learning with Summit Excel for fault detection? Okay. That's well, today we are not going to talk about that thing up. Maybe in the future, I don't know. But today we are going to focus on OpenCV. All good. Hello, Alberto. All good. Hello, Sujai. All good. Good to go. Hi, sir. Okay. So apparently everything is going fine. So let's go to work. Then, first of all, as always, what I'm going to do is to share with you guys. Let me do it right quick here. I'm going to share with all of you the link here of today's project. Let me paste it here real quick. There we go. And now it's time to switch the screen to my computer screen so that we can start working. But before, let me get a quick drink here of my ROS Developers MOOC, as always, in order to get some energy to be able to do this live class properly. There we go. I'm ready and set up. So let's switch to my computer screen, and here we are. So I have just shared with you guys this project, the project for live class number 95 on OpenCV for robotics. Then as always, click on the link or paste the link to your URL, and you are going to get this project in your workspace. If you don't have an account in the ROS Development Studio, just create it. It's free and it's going to take just a few seconds. So once you are logged in and you have clicked in the project link, you are going to have this project here available in your workspace. Then once you have it, just click on the open project button here, and this is going to start loading the environment. Yes, probably most of you already know all this, but well, in case there are some new people here who is new to ROS.DS and to working with projects, it's always good to repeat it. Then this is going to start loading, as you can see. Then while this keeps loading, as always, let's explain a couple of things. So in this case, I want to just talk about the ROS Developers Day, because we are getting really close to the day. So let me come here to the web page, and in fact let me share the webpage with you guys as well. There we go. Then yeah, so we are super close. In June 27th we are going to have the ROS Developers Day, which is going to be a day where we are going to have several conferences about different ROS topics and done by many ROS experts of different fields. So currently I think we already have all the lineup here presented, so you can check it here, all the presentations and which time they are going to be, what they are going to be talking about, and it's going to be all in the same day, in June 27, and it's going to be in the same format as live classes. So each of the speakers is going to share with you at the beginning of the speech a project, like I have just done with you guys, with the live class project. Then at the beginning of each of the speakers is going to share with you a project which is going to contain the presentation and all the data about that presentation, and with all the commands and everything you need to do, so that not only you are going to be able to listen to this speaker and listen to what he is going to explain, but you are going to be able to practice along these 50 minutes that it's going to last every speech. So you're going to be able to listen, to learn while you practice on that same topic. Yeah, so it's going to be super interesting. I'm sure that you're going to learn a lot. I'm going myself to learn a lot, because I have already seen some of the speeches and they are looking amazing and super interesting. So I'm also going to attend and learn a lot from these speakers. So yeah, if you are interested, just come here to this webpage and register. Yeah, because it's going to be next week, so it's here. Yeah, and finally I want to do a shout out to our sponsors, which are Eprosima, Robotics, Micro ROS, and also the two recent additions, which are Apex AI and Neobotics. So thank you very much for supporting us and for making this ROS Developers Day possible. And yeah, that's it. So let's come back to our project, and here we have it. So it has already loaded. Let me make this bigger with the project. All right, so all of you guys, maybe some of you have the project still loading, but it's going to load soon, don't worry. Then when your project loads, you are going to have something like this with the notebook. You have to make sure that the notebook is this one, the one for live class number 95 and OpenCV Basics for Robotics. Then as always, here you have a couple of courses that you should do in order to be able to follow properly this class, which are our free courses, Basics, Linux Basics and Python Basics. You can have a look at our Ignite Academy to these courses. They are completely free, so you can do them. You can complete them 100% for free. And in this case, we are going to be working with a simulation as well. So in order to start it, I'm going to do it right now. In order to start it, you have the step described here. All you have to do is to come here to the simulations button here at the top menu and click on the choose launch file. Then from here, in this case, you only have one launch file possible, so it's super easy, no mistake possible here. So just choose this course simulation launch file and click on the launch button. Then this is going to automatically start the gazebo simulation. As you can see here, let me put it here and make it a little bit bigger. And if everything goes properly, we should have something like this, which is this Hector quadrotor drone in this kind of forest environment. Yeah, so we should have the simulation loaded here. It's almost there. Okay, in case you have something like this, which the drone gets duplicated, like in my case, do you see there that I have this drone which is static here, but I have another one which has, this is some errors because of the renderization. So in this case, just click here on the reload button, and this is going to refresh all the renders and it's going to show the simulation properly. You'll see right now. All right, so here I have finally my simulation properly loaded. Let me make this go a little bit behind. So you should have something like this. As you can see, this is like a kind of forest, this house in the middle of the forest environment with the drone flying right here. Yeah, so once you start the simulation, your drone is going to automatically take off here, and it's going to keep here static rotating on its z-axis, like mine is doing. You can see that it's rotating constantly. Yes, so this is what you should expect from your gazebo simulation. Then yeah, this is what I need you to do in order to be set up for this live class. So have the project opened, of course, then have your notebook here prepared in order to start following the instructions we have here, and have as well the gazebo simulation here prepared and launched in order to do some work, because we are going to be doing some work with this simulation. So yeah, let me know, guys. Let me know again in the chat, in the comments. Let me know if you are ready to start with the live class. You have your project ready with the simulation, notebook, everything prepared. Let me know, guys, so that I can keep going. Let's see. I'm seeing some strange messages here in YouTube. Okay, but I think everything is fine. It just maybe it goes a little bit slow, the stream, I don't know. All right, hopefully not. All right, so yeah, ready. Okay, excellent. So everybody is ready and prepared for starting this live class. Excellent. So then let's go for it. So okay, so yeah, as I've said at the beginning, this live class is going to be about CV, computer vision, basics for robotics. Yeah, then computer vision, which is commonly abbreviated as CV, basically is a field of study that allows a computer to analyze and kind of understand an image or group or groups of images like videos. Yeah. Then the main idea of CV is to improve tasks that could be exhaustive or repetitive for humans. Yeah. Then in recent years there have been many improvements with the apparition of complex computer vision and deep learning systems, like neural networks, for instance. Yeah. So this has pushed and has allowed to advance in more complex fields such as face recognition, facial recognition, and etc., which required a big computational resources. Yes. So yeah, basically, let's say that summarizing, let's say that computer vision is a field which main goal is to let computers analyze and study images or groups of images. Yes? So basically this is the field which analyzes images. Yes? Then what is an image? Okay, so for us an image, we can understand an image, we humans, we can understand an image as a visual representation of a particular static moment, in the case of an image, or of a moment in case of a video or a stream. Yeah. Which is represented by different characteristics such as color, shapes, etc. Yes? So for us, this is an image, but for a computer, an image can be described as basically a matrix, as you can see here in this image. Yeah? So in this matrix, every value is considered a pixel. Yes? So basically it's a matrix which is formed of pixels. Each of these squares would be a pixel. Yes? And then, in case of colored images, we would have a three-dimensional matrix like this one, with the three very known components, which are RGB. Yes, red, green, blue, which are the basic colors. Yes? Then for a computer, for a machine, this is what an image would look like. A three-dimensional matrix with the three components RGB. Yes? So for instance, when we talk about a 1080 pixels image, which is very, very common nowadays in televisions, in gaming, to talk about this kind of stuff, like 1080 pixels, 4K, 8K, etc. What we are talking, what we really refer here is about pixels. Yes, so for instance, a 1080 pixels image, it's basically a 1080 per 1920 pixels matrix. Yes, this is basically what we are talking about. Yes, so this is the basic. The basic way of describing an image. Yeah, because for a computer, computers can understand images in more complex ways. Like for instance, constructions which are the result of light over an object surface, for instance, or the lack of light, for instance, which basically it's the color black. However, let's just keep it simple and say that basically for a computer, an image, it's a matrix. In this case, a color image, it's a three-dimensional matrix. All right, then let's just so this is only the introduction, so I don't want to lose much time here. Yes, I think that the main idea is understood. So let's go straight to practice, because in this live class I want to do a lot of practice. Yes, which is really how I think you are going to get this better. Then first of all, what I want to talk is about the CvBridge. Yeah, so because we have CV or OpenCV, which is an open source library for computer vision, which provides many libraries and many algorithms for analyzing images, etc. Yeah, probably most of you already know or have heard or read something about OpenCV. Yeah, so basically OpenCV is this. It's an open source library which provides many different algorithms for analyzing images. Yes. Then in one side we have this OpenCV, and in another side we have ROS. Yes, because we always in robotics work with ROS. Then what happens? So in ROS, images are described in a very specific way. Yes, so in ROS, images are described with a specific message, which is this one. You can click here in order to see the structure. Yes, it's this image message which is contained inside the sensor messages package. Yes, this is the message in ROS that describes an RGB image in this case. Yes, with the header, height and width of the image, the encoding used, the data array here. Yes, so for instance, here in our drone, let me open a shell here real quick. So if I do a ROS topic list here, I'm going to get all the topics from the simulation, and here at the top I'm going to be able to see all the topics associated to the camera. Yes, because this drone has a camera here mounted on it. Yes, then here I can see topics for the depth camera, which in this case we are not going to look into, and the RGB camera. Yes, so for instance here we have the image raw, which would show us the image that the camera is capturing right now. Then let me copy this topic name here. Then if we do a ROS topic info of this topic here, we are going to see that the type of message used it's this one, yeah? The image message from the sensor messages package, which is this one that we have just checked here, yes? Then in ROS, images are described in this type of message, yeah? However, in order to be able to analyze these images which are captured from our robot and which are in ROS format, in order to analyze them using the OpenCV algorithms and the OpenCV libraries, we have to convert it to OpenCV format. Yes? Does it make sense? Then for this, in order to convert these images to OpenCV format, to CV format, what we use is the CvBridge. Yes? So we have ROS, our ROS environment, in this case it's the gazebo simulation, then we are capturing images with the drone which are in the ROS image message format. Yes, this sensor messages image message. Then we use CvBridge in order to convert this image into an OpenCV format image, which then can be analyzed using the algorithms and libraries from OpenCV. Yes? Does this make sense? Let me see the chat here. Felipe says, my sim drone keeps flying higher and higher. Okay, it should stay static here at some point here, more or less at the height of the roof of the house. Yes? As you can see here, it stays more or less at this altitude, static, and then just rotating here on the z-axis. Looks good. Okay. Alright, so, well, let's keep going. Then, okay, so how does this apply to our programs? Then, in this case, we are going to be working in Python, as we usually do. Then, in order to do this in a program, we will do something like this. Here we have the three defined lines. So, first of all, here we import the CvBridge module from the CvBridge package. Yes? So first of all, we need to import CvBridge. Yes? Then we create an object of this class. Yes? This is a class, and here we are creating an object of this class in line number 2. And finally, what we do in this line is to call this function image message to CV2. Yes? As you can see, from the CvBridge class, here we are calling a specific function which is image message to CV2, where we pass basically the image itself, so the image which is in ROS format, and we pass, or we specify as well the desired encoding, which usually, as you are going to see later, is going to be BGR8, yeah? Which is the default encoding for OpenCV, yes? Then, basically these are the three lines, the three most important lines which define this process that we have explained here in this graphic, yes? So we import CvBridge, we create an object of CvBridge, of this class, and then we call the specific function which does this conversion, yeah? Then this would be a simple code which would do this, yes? So here we have a very basic code, which we are going to test in a moment in the simulation, but basically you can see here a basic example of code where we are importing a ROS, we are importing the image message, the image in ROS format, we import then CvBridge, and we import as well CV2. Then here we define our class, which in this case it's named showing image. Then here we are creating a ROS subscriber, which is going to subscribe to the topic, to this topic, camera RGB image raw, which is the topic where this drone is going to be publishing the images. Yes? So we create a subscriber for that topic. We create an object of the CvBridge class, as we have explained it before, and then basically we are going to, in the callback of our subscriber, we are going to keep transforming. Here we are calling the image message to CV2 function, where we are passing the images captured from this topic, and we are transforming them using the BGR8 encoding. Yes? So super simple code here. Then we have the main function, basically, where we define the node, we create an spin so that the subscriber keeps alive, and all this, which it's basic ROS stuff, so I'm not going to explain it again now. Yes? Yeah, so does it make sense, more or less? Are you following, guys? Let me know in the chat if you are following what I am explaining, or you are completely lost. Let me know, please. Junkai Zhao, can we not directly analyze the ROS image message in OpenCV? No, we need to convert it. We need to convert it to OpenCV format. Junkai. It stopped now. Okay, so Felipe says that his drone has already stopped going up. Great. Alright, then some basic functionalities also that they are very important. We're working with images in OpenCV are how to load, how to write, and how to show also an image. Yes? So this is super important in order to know what's going on and be able to see the different stages of analysis of our image. Yeah? So here we have some examples, for instance, of the EM read, which is this EM read function is used to read an image file, and the EM show function, which is used to display an image in a window. We are going to see this right now, yeah? And we have also the EM write, which is going to basically write an image file, yeah? So it's going to create a file in our workspace, in the location we want, is going to create a file. Yeah, so we have these three very basic functions. EM read for reading images, EM write for writing images, and EM show for visualizing images. Yes, then let's test this real quick here in a very simple example. So for this, I'm going to open here a shell, and I'm going to open an IDE as well. Let me put it right here so that I can visualize my images and my files, sorry, and everything. There we go. Then, first of all, what I'm going to do is to create a new package here, a new ROS package, which I'm going to name, well, let me refresh this because it looks like my IDE is stuck. Let's see. Okay, there we go. It just took some time to load. Excellent. Then, yeah, here we have our CatKing workspace where we are going to create our package. So, let me come here, CatKing workspace SOC folder. And I'm going to just copy paste this command here in order to create my new package. There we go, cat create package live class ROS.py. So this is going to create here in my src folder a new package, as you can see. Whoop. Here I have it, which is named live class. Then inside this package, I'm going to create a new file named loadimage.py. So let me do this right now. Loadimage.py. There we go. And then, I don't know if I'm having some problems with my internet connection, because this is going super slow here. It's going slower than usual, but well, let's just try to keep going. Okay, so I'm going to copy now this code I have here in the notebook and paste it to the new file I have created right here. There we go. Then also I'm going to create a launch file. So let me create here a launch folder. There we go. And inside here, inside this folder, I'm going to create the launch file, which is going to be named loadimage.launch. And in this launch file, I can paste the code I have right here. There we go. Let me save. Okay. And then last thing I should do is to make sure that my Python script, which is here inside my package in the src folder, make sure that my Python script has execution permissions. So chmod +x the loadimage.py script. There we go. So now it has execution permissions. Excellent. Then let's analyze very quickly this code, which is super simple. So basically what this code is going to do, it's the following. Then here we have our code. Then we are importing ROS.py. We are importing the image ROS type. We are importing CvBridge, CV2 and OS, which are modules. CV2, this is for computer vision, of course, and for being able to call all these functions, emread, emwrite, etc. And OS, which is going to allow us to basically to move to a certain directory. Yes. Then here we have our class, which is called load image. We have the subscriber, where we are subscribing to the camera /RGB/image raw topic. Yes, which is the topic where our drone is publishing the images which is capturing. Then we create here the object of our CvBridge class. We are converting here all the images captured. We are converting our ROS images to CV format, as we have seen before. And then here we are setting a path. Here, home, user, notebook, workspace, images, course images, test image. So here we have an image, JPG image, which is for testing, because then we are going to use this image here to show it, to visualize it. Yes? You can see here we are saving this path, this image path, into the example path, and then we are reading this image using the emread, the image read function. Yeah, we have it here. So we are using this emread function, we are reading the image, this test image 1, which is in this specified path. Yes? Then here what we are doing is to move to a certain directory, which is home, user, cooking, workspace, src, live class, src. So we are moving to this folder, to the folder where this script is, and here we are writing an image, which is named drone image. This is the name that we are going to give to the file that we are writing into this path, And what image we are going to write here? We are going to write this CV image, which happens to be the image that the drone is capturing. Yes? And then finally here we are calling the image show function, and we are passing this test image. Yes? So basically, in this script, we are doing two things. First, we are reading and visualizing this test image 1. Yes, which is in this path here. And then and then also what we are doing is to save the images. Well, in this case it's 1, which is going to be it's going to save one image that the drone is capturing, and it's going to save it into this path with this name, drone_image. Yes? Does it make sense? So basically, once we execute this program, we should be able to visualize this test image 1, and we should see a new image appear here in this directory named droneimage.jpg. Yes? So let's test this. Let's see what happens if we execute our program. So I'm going to come here and do a ROS launch of the live class package and load image.launch. There we go. Then one thing I'm going to need to do is to open the graphical tools. Let me open them here in a new window so that I can visualize images with the em show function. Let's see. All right. So here I am visualizing this super nice image from a galaxy. This image, it's this image here, this test image 1, yes, which we are reading and visualizing here with the emRead and am show functions, yes. And then also we can see that a new file has appeared here named drone_image, which is the image captured by the drone, which I have written here with the imWrite function. I have written into this path here. Yes? So for instance, I can download this image. Let me download it here. And if I open it, I should see an image captured by the drone. So let's see if this loads properly. There we go. So in this case, the image captured, it's from the roof of my house. Yes? So when I captured, when I executed this program, the camera was facing the roof. Yes? Does it make sense? So if I, for instance, if I run again my program, probably this image is going to be different since my drone keeps rotating. Yes? So let me do this and see what happens. All right. Let me close my program and let me download again the image. And now, as you can see, the image happens to be from these trees that we have here. Yes? So let me close these images now. All right, so basically with this simple program, we have seen three very basic functions of that we can do with CvImage, which is to read an image. Yes, read an image and save it into a certain variable, show an image, show it using here the GUI, so in order to visualize a certain image, and then how to write an image into a file. Yes, so a certain image that I have captured here from the camera of the drone, I can write it into a file. Yes? All right, excellent. Then let's keep going. So we have seen these basic functions. So now we are going to okay, yeah, here we have another example, which basically, yeah, let's do it super quick. So let's create here another script, which is going to be named loadimage2.py. Then we are going to copy and paste the code we have here. Let's do it super quick. Let me select the code here. Control C, and Control V. There we go. So super simple. Basically what we are doing here is to, there we go, is to read the image from this path, which is the image that we have saved with the previous program. Yes, this drone image JPG, then we are reading this image here with the IMRead function, and then we are showing this image with the IMShow function. But at the same time, we are generating another visualizator calling the IMShow image with the CV image, which is the real-time image that the drone is capturing. Yes, so basically here we are generating two visualizators. One is going to show me the image, this static image that I have saved here into this folder, into this path, and the other is going to show me the images that the drone is capturing in real time. Yes? So let's execute this program. First of all, remember to make sure that it is executed, that it has execution permissions. So chmod +x load image to .py, and we are going to need also to modify here in the launch file, instead of starting the load image program, we should start the load image to.py program. Yes? Then let's, whoop. What's going on here? Let me close this. All right. So yeah, then let's run again our program. There we go. And now here we should see in one side the static image, which should be the one with the trees, if I'm not wrong. There we go. So here we can see the static image with the trees, and here we can see the current images that the drone is capturing. Yes, as you can see, the drone keeps rotating here on its z-axis, and here we are seeing what the drone is visualizing at each moment. Yes? So yeah, basically these are some basic tools that you need to know when working with OpenCV, and how to read, visualize, and how to write images. Yes? Then let me close the program right now. There we go. All right. Let's keep going. Yeah, so here you see the expected output. Then space colors. All right, give me just 1 second so that I get here a drink, because I'm getting my throat very... All right, so so far so good. Let me have a quick look here at the chat. Okay, apparently there are some internet issues. A stream is cutting, mine too, me too, same here, internet issues as well. Yeah, I think the internet is slow on your end, Alberto, the stream is choppy. Yeah, I also think so. Because while working, I am, yeah, my sensation is that everything is going slower than usual. So I think I'm having some internet issues here. I don't know why. This could happen. This could be happening where we are having some rain here in Barcelona today, but I don't know. I mean, shouldn't be a problem. But yeah, I think it could be related to these internet issues, because I'm also seeing some messages here in the YouTube live manager here, which is telling me that that the video stream is not very fluid. Missing half of what you say. Damn. Stream is cutting off. Okay, so that's a pity. Okay, now my messages here in the line, no, they have returned. Better now. Better now? Is it better now, guys? Let me know. Hopefully, yes. Gloria says, screen frozen on the ID5, but I am following the Jupyter Notebook instructions. Yeah, in case the image, the video is not working properly, remember that you have the instructions as well in the notebook, so you can follow them there. I'm sorry, really, I don't know what to do, because, yeah, I don't know. I am also seeing here from my end that everything is going slower than usual. Yes, in previous live classes everything was better, at least. But today I don't know what's happening. Maybe the internet provider is having some problems. I don't know. Is it still working wrong, guys, or it's a little bit more fluid? I'm doing some changes here. I don't know. I'm not reading new messages. All right. Well, I'm going to keep going, and hopefully, guys, you can at least you can listen to what I say, and you can combine what I say with the instructions in the notebook, etc. Okay, great. So I'm going to keep going. Then, all right, space colors. Then space colors basically is a space color. Basically, it's a three-dimensional model that tries to describe the human perception of a color. Then, basically, this is the each coordinate of this three-dimensional model defines a characteristic for a specific color. For instance, the most commonly known, which is RGB, we have a value for R, a value for G, and a value for B. Then, depending on the value we have for RGB, yeah, so RGB visualizer, color visualizer. Let me open this, for instance, super quickly. Yes, so in the RGB model, basically we have three values, R, G, and V. Yes, then depending on the value we set in each of these fields, this is going to define the resulting color. Depending on the intensity we apply of the red color, the green color, or the blue color, we are going to have a resulting color. Yes? Does it make sense? So this is the RGB color space. Yes? However, in OpenCV, and in this case for color filtering, there is another color space which is better to use, which is HSV. This one, yes? The hue saturation value. HSV color space. Yes? This is easier in order to be able to do color filtering. Yes? Then, in this case, if we want to do a color filtering using OpenCV, what we are going to have to do is to do a conversion from the RGB In fact, it's BGR, because in Python usually works with BGR. Yes, but basically we can do conversions. Yeah, the main idea is that we can convert from one color space to another one. Yes, so we can convert an image from an RGB color space to an HSV, hue saturation value color space. Yeah. Then for color filtering, the HSV color space, it's better. It's easier to do color filtering using this color space. Yes, for the algorithm, it's better to use HSV. So what we are going to do here is to do a conversion here from the BGR format to the HSV format. Yes? Then this is done. Here we can see an example of how to do this quite easily. Yes, here we have it. So first of all, we can see here that we are doing a EM read. So we are reading a certain image and we save it into this image variable. Then we do a resize of this image in order to make it smaller and make it easier to work with. Yes. Then here we call this CVT color function. So basically what we are doing here is to change our image, this one, from the BGR color space to the HSV color space. Yes, this is what we are doing here. Then here we have some other operations that are more related to color filtering. Yeah, so let's go into them. So basically here what we are doing is to define in the HSV color space, we are defining some thresholds, some minimum and maximum values. Yeah, so for instance, we are doing this for the green color, the red color, and the blue color, because these are the colors we want to filter. Yeah, so remember that our purpose is to filter the different colors from this image here. Yes? Then here we are defining the minimum and maximum values for each of the colors. Yes? So this is the minimum value that would consider green and the maximum threshold value for green. Yes, these values that we have here in the array are basically the values for the HS and V values respectively. Yes, each of the values of this vector. Then this combination of values would define the minimum. Yeah, so basically this defines a shade of green, let's say. Yes. And this defines another shade of green. This would be a light green. Yes. These values would define a light green, and these values would define a dark green. Yes. Then for all the colors between these two shades of green, we would consider that as green, and we would filter that as green. Then if it's outside these threshold values, then that would not be considered as green. Yes? Does it make sense? And the same for the red and blue values. Yes, so we are defining a minimum and maximum threshold values in order to consider that color red. Yes? If it's outside these threshold values, it's not going to be considered red, so it's going to be filtered out. Yes? And then we are doing finally the same here for blue. Yes, here we are creating then, once we have defined these threshold values, we are creating masks here. Yes, we are creating masks so that we are going to filter and only keep the colors which are inside our limits. Yes? Does it make sense? Okay, so what? Oops, here I have many things missing from my notebook. All right. So here I should have more things which I am not visualizing. Give me 1 second. Okay, let me go real quick to the chat. Okay, give me one minute, guys, because here I am having some problem because I don't know why. I should see here all the notebook and I am not visualizing. I don't know. Are you seeing more of the notebook, or is your notebook also ending here? This should continue, this notebook. I don't know why it's stopping here. Is your notebook also finishing here, guys, or do you have more below this? Okay, let me see here. I don't know if I am. I think I'm not reading you guys right now. Are you able to listen to me? Let me know in the chat, please. Guys, can you listen to me? Can you listen? Notebook ends there for us too. Okay. Now I have seen the Engineering Nations. Okay, right. So I don't know what happened there. A problem here in the while saving. However, I'm going to keep going and just do it normally. So in your case, what you can do, guys, it's to, well, don't worry. What I'm going to do is to when this live class finishes, I'm going to fix this issue and put here the full notebook, the original notebook, and then you are going to receive here in your project, you are going to see in the project that you have, you are going to see here a mark saying that the original project has some updates. Click here, you will see, here you have it, yeah? So you will see something like this. Then once you click here, it's going to ask you, do you want to get the latest changes? Then you click yes, and then you are going to receive the latest changes. And basically what I'm going to do here is to update the notebook, because this is not the notebook I've made. There are many parts missing here. So yeah, I'm going to do this, okay guys? So I'm going to update the notebook with the full content, and then you're going to be able to receive the final version by clicking here. Yes? Alright, so meanwhile what I'm going to do is to create this. So I'm going to create my program. I'm going to do it here from zero in this case. Yes, in order to, so remember, the main idea is to filter this image here. Yes? Then let me create here a new file. So I'm going to create a new file here named filter colors.py, for instance. Filter colors.py. Alright, there we go. Then let me try to, I'm going to modify this so that it's easier for me to copy it. Let me change this to code mode, and let me remove this. Okay, so this way more or less I'm going to have a base for creating the program. There we go. Okay. So basically, let's go line by line and build the program more or less from zero. Yes. So first of all, we are going to need to, as always, user bin env Python. So we said that this is a Python script. Then we import ROS. We import well, in fact, let me do one thing, because most of the code, I'm going to be able to reutilize what I have in other programs. So I'm going to actually remove this, and let me, for instance, grab this one and modify it here. Okay, let me grab this code here. I'm going to do it based on this one. Filter colors, there we go. Save. Okay, so I'm going to just do the modifications right here. So what do I need? Okay, things that I need. Let me see here. I'm going to need MP, which is NumPy. Yes, so I'm going to need to import this. Here I have it. So I can grab this from here and paste it into my code. There we go. Then I need to subscribe to, well, this I can leave it because I'm subscribing to the image. Then I need to know here the path to the image I want to analyze, which in this case, in this specific case, it's this one here. Yes, then the path is this one. I know it. I'm going to put it here. So it's images here, it's course images. This is going extremely slow. Don't know what's going on, but it's super hard to work like this, really. Well, let's just try to finish this. And all right, so okay, so this is the image. It's in this path: home, user, notebooks, notebook workspace, images, course images, filtering.png. Yes, this is where I have saved this image, which is the one that I want to filter. Then, all right, I have my image in the path. Then what else? Next thing I'm going to do is to, okay, yes, here is where I am actually going to do all this. So try to, okay, there we go. Let me try to now copy and paste this code. Now, yes. All right. I'm going to place it here. All right, let's see. Then, okay, we get the image. We read the image first of all. There we go. We read the image from our example path variable, which we have here. We resize our image. Next step. Then what else? Let me look here real quick. All right, then we have the conversion here with the image. Okay, this is fine. Then we have to define the threshold values for green, red, and blue, as we have explained before. Then we have here already the thresholds defined. Then we have the masks. We create the masks. We apply the masks here, and then we show the results here. Okay, so this is almost everything done. So here all I would need to do is to add the missing ones, which are, I think this is going to work fine. I will need to add the ones for red and blue, which are the res R and res B. And also it would be nice to add the original image here. Let me add it here at the beginning. To add here the original image, and this is just the image variable we have here. And yeah, I think no, this is going super bad. All right, I think we have it. Okay, so I think this is more or less the code I would need to do. So let me just test it real quick. I'm going to try to execute this here and see if it works. So execution permissions. ROS run live class. I'm going to run it there. I'm not going to create a launch file for this one. Let me run it and see if it's okay. I have some problems here. Line 32. It's complaining here about line 32. What do we have in line 32? Okay. Let me just remove this. We don't need it, so I just okay. Save this. This is almost impossible to do anything like this, really. All right, here we are running our program, and apparently it's working. So let's come here and check the visualizer here. Okay. Nothing shown yet. Okay, I am not visualizing anything. I don't know why. I should in green, mask G. Oh yeah, I think I need, yes. 1 second. I think I need to add the weight key. C2. We go, because I am not closing anything here, right? Load image or spin. Yes, here I have it, everything running. Okay, yeah, let's try to run it one more time. And if this doesn't work, guys, I'm going to close the live class because it's almost impossible to do anything with this quality. Also, the notebook, it has disappeared, half of the notebook. Well, today, clearly it's not the day. All right, well, hopefully we have been able to create this code to show it. All right, guys, yeah, so here we have the original image and here we have the filters. Here we have the filtering for the red color, the blue color, and the green color. Yes? Then, yeah, guys, so I'm going to close the live class here because it's impossible to work like this. I don't know what's going on here, but the internet is going super slow. Also problems here with the notebook, with many parts here of the notebook missing. So yeah, I'm going to close it here and I'm going to do just what I've said. So I'm going to update here the notebook to have the correct version of the notebook, and then you are going to be able to download it to your project versions to get the latest version. Yes, which you are going to have all the code and everything, because here I had to do it myself manually, the code, so that I could show you this. And yeah, so I'm super sorry. I don't know. So today it wasn't the day. I had many problems here in the. Let me see here the chat. It's the end. I don't have code of color filtering in my notebook. Yes. Can hear you. Be careful with what you said. No groserías. Yeah, Felipe. Yeah, but it really pisses me off because I don't know. I have been preparing this live class and now it comes the time where I have to do the presentation and the internet is not working properly. It's going super slow and everything is super hard to do. Then for some reason now the notebook, half of the notebook has disappeared. And it really pisses me off. But well, I'm going to try to, yeah, let me just close this. So yeah, guys, I'm really sorry. My apologies. So for next live class, I'm going to make sure that the connection is good before I start. I'm going to make sure that everything is perfect. Yes. So yeah. Now what I'm going to do is to try to find out what happened with the notebook. I'm going to just put there the latest version and then I'm going to save it so that all of you can get the correct version of the notebook with all the codes and everything, so that you can complete it by yourselves. We have done almost everything, yes. So the next step was just to apply this to an image captured from the. I have showed you now the color filtering algorithm, and then the next exercise was to basically apply this algorithm but to an image of the drone, yes, in order to filter different colors in the images of the drone, for instance, for filtering the grass, the water, etc. Yes. So yeah, I'm going to update the notebook so that you can get all the codes and everything there. And yes, that's all. So I'm really sorry today. The experience was very bad, but well, I promise you that I'm going to improve it for next live class, guys. I'm going to do whatever I can. Everything is in my hand so that we don't have this kind of problems. And yes, I'm going to see you next week in next live class. So thank you very much. Thank you for your patience, and I will see you next week, guys. Bye bye.